This conference will now be recorded.
Fine, guys, we'll get started. Thanks once again for joining this session. Um, Hope you're able to see my screen. Okay, so today I'll be providing the overview on the engineering course, which is scheduled to start from tomorrow. Okay. So I'll probably give a brief introduction about me. I'm Satish. I'm in the IT industry for close to 14 to 15 years with varied experience from performance testing to engineering and then product development. And also been taking this engineering training for last 3 to 4 years. That's a very quick, short introduction about me. So what we will do today is I'll walk you through the complete course details, various topics that we will be learning as part of this engineering session. Okay, so before that, very quick introduction about or quick overview about the importance of engineering in the current market, current world, right? I believe that maybe most of you might be having some kind of experience in performance testing, maybe 3 years or 4 years or 5 years. Maybe you might be doing some kind of engineering, or if you might be test managers, performance lead, performance manager. That is what I guess the skill set you everyone would be having it. Being a performance tester or a lead, most of the time, even when I was doing performance testing role, so we will be focusing on, say, some kind of a requirement gathering to get the your workloads and then critical transactions, and then we'll be using JMeter or load runner for scripting, and then execution will be part of our role, and then we will be doing basic analysis. Sometimes we will do monitoring if access is given. If not, we will stick on to load runner or JMeter kind of analysis, and then we will provide the report. Depending upon the nature of the project or the skill set, um, uh, project to project, we might be doing only scripting, or few might be doing only scripting and execution, and only few might have got the end-to-end testing, and few might be involved in requirement gathering, right? And there were specific team who will be taking care of the performance engineering in the past, right? Who will be after you provide this report, they might be parallelly monitoring the system to identify the bottlenecks, to provide the recommendation, to do the code level profiling. All these things will be taken care by the separate architects within the development team, or probably it will be done by the separate performance engineering team. Right? Now, with the current market, with the current digital world, where you have DevOps teams, where you have small agile pod teams, right? Uh, the role is getting optimized. The various roles are getting merged into single one, right? Even we are seeing a situation where one person should to do functional testing, performance testing, all kind of testing, your full stack testing, what they call, right? So while these roles are getting merged, definitely for performance, we're not going to have a luxury of having one person to do scripting execution, one person to do analysis, one person to do engineering. So it is it is very much now going to be the one single person who has to do multiple things. Also, a lot of things are getting even automated in DevOps world, right? Which means the role of the performance testing itself is always going to get questioned, because your executions are getting automated in Jenkins. Your even scripting is also getting automated. The lot of tools in the market now, they are trying to even automate the scripting itself. Right? They say no correlation. They say scripting will be created by the tool itself. So which means it is very important for a performance tester to pick up additional skill set so that we stay relevant in the today's market or in the near future. So with that, performance engineering is the extension of performance testing, which is going to add definitely a lot of value to your resume or a lot of value to your current role as well. So when it comes to performance engineering, right, it is going to be a combination of couple of skill set. Whatever you see in the slide, right? One is testing, obviously. One should know what are the performance related parameters, the requirements, scripting, execution, creating various scenarios to load your service. So testing is going to be one part, which I believe most of you might be already doing it, right? And second is going to be your system analysis. That is going to be your huge chunk of performance engineering, right? The third and fourth are going to be good to have, and maybe at a minimal level, you're programming and some kind of networking skill set or networking experience or system administration kind of experience, right? So programming and networking or administration is good to have in the current scenario, and that is also going to be part of your performance engineering. But the larger chunk is going to be your system analysis. So when I say system analysis, it is going to cover a lot, which we will look into it in the another 5 to 10 minutes. But that's going to be a combination of a performance engineer. You should be able to test it. You should be able to understand the programming language, because performance engineer is going to closely work with the developers. You should be able to speak in that language, but doesn't mean that you should know core programming. You should have expertise in Java or Python. That is not the requirement. At least the basic things, whatever engineering recommendation we are going to do, we should be able to talk in a similar language like a developer. That's all that is required from a programming language, more of a good to have. Similarly, networking, to troubleshoot some of the network problems, network latencies, and to install the tools, to install the softwares. So those administration and networking is also important, again, because in current DevOps world, you should be able to build a code, you should be able to deploy a code, you should be able to start the server. So all these things are going to be part of your system administration, right? So that is also going to be part of a performance engineer. So combining all together is what it is required. And the engineering course is also designed in such a way that you would be able to meet these criteria for you to pick up these skill set. Okay. Okay, when I say system analysis, right, I said it is going to cover a lot of things, right? When we say system analysis, it is going to start when the development is going to start, right? Where you're going to get involved in doing your unit level profiling, be it as a client side profiling, or if it is going to be, it is going to be your API profiling at the dynamic code, taking a module and then doing a profiling to identify response time bottleneck, and then memory leaks, your threat contentions, heap dump analysis, thread dump analysis, your database analysis, AWR report analysis, right? All these things are going to be a part of your system analysis, monitoring your all the software components which are part of your architecture,
Satish,
creating a
one quick thing. Sorry to interrupt. In this course, you are going to describe all these things.
Yeah, let me go to the next slide where I will show you all the course content. Just give me 2 minutes.
Sure.
Yeah. All these things are going to be part of your system analysis. And you should be also be able to write very good engineering strategy. You might have written test plans, test strategies, but engineering strategy is required as a performance engineer. right? And reviewing your system architecture, and that is very important, or good to have if you're going to be part of a greenfield implementation. And if you maybe not immediately, right, as a fresh performance engineer, you will not have experience to go and review the architecture, or recommend something at the architecture level. But as you move along, once you gain experience, once you gain confidence, then you should be able to even go and review the architecture, see whether the your response time SLAs or the non-functional requirements given by the business team, whether it can be achieved through this architecture or not. Those kind of review will also be done by the performance engineer. Yeah. So all these going to be part of your system analysis, which is going to be one major quadrant as part of a performance engineering. Okay. This again, I'll come back to this. This just shows you different engineering activity at the different SDLC level. One important thing we should know here is, if we are going to be only performance tester, right? See, if a product is going to get developed in 1 year time frame, from January to December. So normally what will happen is, our performance testing team will get engaged in September or October, or maybe August, right? And then we'll be start doing a scripting, execution, and analysis, right? Which means our role is going to get only confined to those 2 months or 3 months. If we wanted to be available, or if you wanted to be work along with the development team, which means our scope of work has to increase, which means we should be able to work along with the development team right from the designing phase. So this is going to tell you how it is going to work. From a requirement, you will work with your business analyst. You're going to work with the product owners to gather the non-functional requirements, and then use that to review your designs, review your algorithms, review your architecture. And while the developer is going to develop the code, you will be part of your server-side profiling, your memory leak analysis, your JVM benchmarking. All these things are going to be done through development stage. And then during the testing, you will be doing both execution or scripting, and also you will be doing a monitoring, and then doing a thread analysis, DB analysis. So if only if you are going to expand your knowledge, you would be relevant for the entire year. Otherwise, you as a single person, you will be confined only for 2 to 3 months. So as I said earlier, now a lot of automation is happening around load testing execution from Jenkins or from other tools, right? So our performance testing scope is getting little shrinked as we move along. So for us to be relevant in the market, we should expand ourselves so that we can start working in a team even before September or August, say from month of March or April. And then the kind of activities what we do is going to cater from business requirement, design, development, testing, and even in the production also. You would be able to do this production monitoring, continuously monitor your application in the production, get a lot of feedback from the production, and get that feedback to refine your workload, to refine your non-functional requirements. So that is a role a performance engineer will play across SDLC cycle. Okay. So to answer your question, what all we will cover as part of the this course, right? I have segregated into a couple of things. One mostly into concepts, and then into early performance or profiling, and then during load testing or endurance testing, and then something for the future readiness. Okay, that is how I have categorized our topics, and I'll just go one by one. First, we'll start with, as I mentioned, one of the important things is we should break a barrier of this programming thing, right? I used to talk about this ways to start an initial roadblock. Always, we as a performance tester, even I had this roadblock, right? Is it possible for me to do engineering? I don't know programming language. I haven't done this any kind of engineering work. And I will not have confidence going and talking to a developer, because even when I do a load testing and I talk about response time problem, they will not agree. They will tell that my script is problem, my test data is problem. It is very, very difficult to go and prove that there is a problem in the code or in the application. So which means now when I'm going to talk about and provide recommendation, I'm going to tell about your code is having memory leak, your code is having that problem. Will developer accept? Do I have confidence in myself to go and talk about it? That is a roadblock that I had. Even a lot of people used to have it, right? That barrier we need to break it. Okay, so that is why I said every one of us should at least know minimal amount of programming, right? When I say programming, we're not going to go and create Java applications by ourselves. We're not going to go and create complex algorithm. At least when we go and do the engineering for Java application, and then we tell about this method is having a problem, this object is having a memory leak, or when we talk about thread, and when we talk about AWR analysis, right? We should know about these things in a hands-on way, right? Ourselves should have created some programs. We should have compiled it. We should have created the war file. We should have deployed it. That is how we can break this barrier, so that when we talk about these recommendations, we can feel confident about what we speak. At least it is not going to be just alpha and beta, right? We know that our class is going to look like in a program. Our object is getting created. Our one object is going to call another object or another method. So all these things we should get a hands-on. So what we'll do is from the session 1, we will cover the Java basics, more from the concept and then the programming. I'll be using the Eclipse to create programs, and we'll go and understand our simple classes created, how multiple classes created, how we go and add external libraries, how we make a call to a database, how we make a call to HTTP calls outside services, and then we go and compile it, and then we will go and create a war file, and then we'll be going and deploying it in the Tomcat, what I have it in my mission, and then that's how we're going to learn the basics of program and feel confident about the class, the method, the object, database connection, your other HTTP connections. So that is what we will be covering it in the first session, the Java basics. Okay. From there, we will move on to the engineering sessions. So we'll start with the JVM basics. So always we will talk about the concepts, and then we will go to the hands-on. Or we'll go and look into the problems, the performance problem. We'll try to I have a Java application available with me, which we will be using it throughout the session for creating a problem and then testing it out. The way we'll do it is we'll build the code, we'll go and deploy it, we'll test it, we'll identify the performance problem, we'll go and profile it, we'll diagnose it, and then we'll go and provide the recommendation. That is how we are going to do it for most of the problems, most of the performance problems. Okay, so probably I'll just, yeah.
So just one quick thing. So based on your past sentence, I mean, what you were saying, that do we need to install any software like Tomcat and these Java applications, or any
Yeah,
framework is
yeah,
required to be installed into our
yes,
laptop?
yes. I'll come to that. So since you asked it, right? So I want basic things to be available with you. It is good to have. It is good to have so that at least during a session, or maybe after the session, or maybe after the batch, you should be able to go and practice it. Unless otherwise you practice it, you will not get that confidence. So I would strongly recommend you to have at least a few basic things. We are not going to install hundreds of softwares. If you have a laptop, you should have a latest Java in it. You should have an Eclipse, a Tomcat, and I will provide you the sample Java application with the code, with the war file, and all the problems what we are going to create, right? Say if I'm going to create a problem for the response time or memory leak or thread, all the code, whatever code we are going to use it, that will be available in the Google Drive. which will be given to you. Say, for example, if it is going to be a response time problem, I'll be having this Java file. I'll be having this war file. This war file is what I'm having it in the Eclipse project. This e-library project is the web application, which I'm using it in the Eclipse. And this is the e-library application, web application, which we will be using it for all our profiling, analysis, testing, monitoring, everything. And that will be available in the Google Drive. So for everything, response time analysis, your thread lock issues, and then if it is going memory problem, memory leaks, all the files, all the scripts, whatever we are going to use it. Like if you wanted to, for the Oracle, we'll have all the SQL commands to create AWS reports, AWS snapshots, DB connection pool configurations, sample AWS reports. So all these things will be shared with you through this Google Drive. And then we'll also maintain a Google Sheet in which I will provide you all the links from where you can download this Eclipse or JProfiler or Tomcat or Eclipse, whatever other references also will be shared through this Google Sheet. And we'll also have a Q&A sheet where you would be able to, if you have any questions that we couldn't able to discuss in the session, you will also be able to post that question so that it will be available for everyone to look into it. And I'll also provide the answers. These are all from the previous batches where people used to ask these questions offline whenever they get these questions, and I'll start answering those. So Google Sheet and Google Drive will be the mode through which I'll be sharing all the softwares and the code and the application to you. And as you asked, yeah, it is good to have these things in your laptop so that you can practice every day or every weekend, or at least whenever you get time. That is recommended.
One more quick thing, that can we get the whatever the sessions we are going to have, the recording of those sessions, so that maybe there is a possibility that we can refer those sessions recordings later on as well?
Absolutely. So you will get the video maybe on the same day or maybe the next day morning, so that even if in case if you miss out for any reason, you'll be able to look into it. Also, post the batch, you will get the access to the videos completely. There is no limitation, time limit to that. So you will have a complete access to all the session videos even after the batch.
Okay.
Yeah. So the way we will learn is, as I said, we will build the code, we'll go and deploy it, we'll go and test it, we'll find problems, memory problems, response time problem, thread contentions, all these problems, we will create it, and then we'll go and profile it. We'll identify the bottleneck at the code level, which method is causing a problem, which code is causing a problem. Since we have a live application, we also have access to the code. We can everything is going to be white box. Nothing is going to be a black box. You, as a tester, you identify a problem. As a engineer, you will find a bottleneck, and we'll go to the code and we'll see exactly where is the problem, and we'll go and fix it. That is how the sessions are going to be for majority of the topics. Okay. So response time. So these after the Java basics, we will start with the JVM basics. We'll try to understand how the JVM is designed, what are the different components, how the JVM works, JVM internals. That is going to be from a concept perspective. We are going to have this, and then we will start the performance bottleneck identification, right? So from a shift left perspective, from early performance, once an application is developed, we will go and fine tune the each and every page or functionality with respect to response time. Optimizing your response time at the method level. So we'll be using the tools like JProfiler. We'll be using the access log from your servers. We'll be using Chrome developer tools for the response time analysis. And then, yeah.
Satish, one more quick thing actually.
Yes.
You are going to explain the things around all the performance engineering concepts, yeah, but I would like to know that you are talking only about the Java applications. Okay, but currently, like I am working onto the SAP application or onto the ERP applications. So would be all these concept will be remain same, or there will be some different things like.
Okay, so to answer your question, right? Obviously, there are going to be n number of technology or n number of
Mhm.
product, right? But two things we need to look into it. One, obviously, from a performance engineering course perspective, will not be able to go and touch each and every technology. That is definitely not going to be possible. Number two, whatever we have taken is the that can be easily applied to any of the other technology or any of the product, be it is going to be SAP Ibris, or say if it is going to be an Elasticsearch database or any .NET applications. The concepts are going to be pretty much same. Everything needs CPU, everything needs memory, everything needs
Absolutely.
processing power, everything needs threads, everything
Hmm.
needs memory. So from a concept perspective, it is pretty much same. But Java being the main old, at least last 10 years, 20 years, even now, uh, everywhere, any architecture, if you see, yes, JavaScripts are coming up, Pythons are coming up. But when you look into
Yeah.
the customer facing web applications, still I see Java is playing a major role. So that is why we picked Java performance engineering for the course perspective. But
Yeah.
most of the concept can be extended to any other technology. Once you master this, then you will
Yeah.
be able to easily apply it to any other technology.
Okay. Okay. Thank you, Satish. Thanks.
Yeah. Okay, Vikas. Okay. Fine. So from there, we will be moving on to the basics of Java heap and stack. More from the JVM internal, very specific to memory. We will try to understand the concepts, and then once we understand the concepts, then we go and create some problem within the code, and then we'll again go and deploy it, and then we'll use tools like JConsole or JProfiler to monitor the memory, and then to identify the leaks, and then again go to the code, fix those leaks, again deploy it, figure it out whether the problem is fixed or not. And then see, this memory leak analysis has to be done at the early performance level for each and every functionality, right? Each and every transactions, we need to do the memory leak, right? But when we move on to the load testing or endurance testing, we're doing a testing phase where we will be running a test across all the workload. Then this heap dump is going to come into picture. When we going to run a endurance test, more or less we more often we see out of memory problem. So during that case, how are we going to take the heap dump? How are you going to analyze it? How are you going to troubleshoot the problem? So that is also going to be part of the next session, where we'll be using again the tools like JProfiler or Eclipse memory analyzer tool plugins to analyze your heap dumps. And then we'll then extend it to the again, all these things are part of memory. Whatever we are talking about, right from a Java heap and stack, memory leak analysis, heap dump analysis, garbage collection analysis, all these things are from the memory perspective. So GC, again, it's going to be a very exhaustive sessions where we will cover the more from the collector's perspective, various parameters that is available within the your heap configuration, where to fine tune the GC parameters, and then we'll also look into various regions within your heap with respect to GCs. So it's going to be an elaborative session to identify problem with GC times. So all these things will be covered as part of the GC analysis. So with this, probably what I would say, 6 to 8 hours of comprehensive sessions will be around this memory. Then we will move along to the threads, Java thread concepts, how Java threads works, what are the concepts behind it, and then we look into the thread contentions, thread connection pools, and then we'll also look into the thread dump analysis. We will go and create concurrency problems when 2 or 3 users are going to access the same functionality. We will create a contention in the code to simulate the deadlock issues or your thread-based situations, and then we'll go and uh, uh, create the thread dumps, and we'll go and do the thread dump analysis. That is how so all these things are, except for concept, wherever we see a word concept, apart from that, everything is going to be kind of discussion plus practical sessions. So we'll have code, we'll have tools, we'll go and run it, we'll go and analyze it. It's all going to be completely practically oriented sessions, apart from the one which are marked as concept. Okay. Then once we are done with the thread dump analysis, client-side analysis is one which we'll focus on. Again, this is very hot topic, and most of the time client-side analysis is not done for most of the web applications in most of the projects, and it is very much nowadays very popular even in your interviews or even in your digital apps. So we'll spend very good amount of effort in understanding what is client-side analysis, what are the tools available. We'll again go and create problems specific to client-side analysis, and we will see how to optimize it, how to provide recommendation to fix it, right? Just not go and get the response time or page load time, just not going to look into the metrics. We'll look into the metrics. Along with that, we'll go and learn what are the various recommendations available, what are the various optimization techniques available, like your JavaScript minification or image compression or content delivery networks, caching efficiency. All these things will practically create problems, and we'll go and fix it. Okay.
Satish,
So
sorry to interrupt you.
No problem. Go ahead.
Will you cover microservices?
Okay. See, when you talk about microservices, right? Behind the scene, it's again the REST APIs, or it could be normal web services, right? And it is going to be built in Java, or it is going to be built in Node.js, or any of the technology. So from an engineering perspective, the profiling, the dynamic code profiling, right? Responsive analysis, your memory leak analysis, your heap dump, your GC, everything is going to be same, even if it is going to be microservices, or if it is going to be a your big Java application. See, to keep it simple, earlier they used to have a very big application. Say, for example, let me show my code, right? Here, if you see, I have this servlet code, and here I have this admin login.java. I have issue book, and then I have add library, and all these things are .java file, right? And everything is a functionality. Add library is a functionality, add book is a functionality, and logout is a functionality. And all these things are going to be part of the one single application, which is deployed in my Tomcat WAR file as a WAR file. Now with microservices, what they have done is login is going to be one single service, and that will be deployed as a single WAR file. So they are now splitted all the big one single application into small pieces, and login would be one microservices, and your add book is going to be one microservices, which means one big WAR file is now getting splitted into 10 different WAR files. So which means our engineering is going to be still same, but more from the JVM benchmarking, right? That might be different. So those concepts we will definitely discuss. How are we going to do this JVM benchmarking for microservices versus your traditional application? Those things we will discuss for sure.
Yeah, thank you, Satish.
Yeah. So from the so far, whatever we have seen.
Sorry,
Yeah,
Satish, Neeraj here. One question. I'm seeing like a lot of tools you have mentioned on the right-hand side, right? So for profiling, like AppDynamics are there, and
Yeah.
then monitoring. But sometimes in interview, like interviewer ask, like you don't have any tool. We are a small company. We can't afford any licensing tool. So in that case, how will we proceeding for performance engineering, like without
Yeah.
any tools?
Yes.
Yeah, that's my
Yes,
question.
I have
Yeah.
also included specifically for addressing this question, right? I think you're right. Most of the time, even in a single company, not every application will have AppDynamics, right?
Right, right.
Because it's a costly tool. So we'll also look into a couple of open source tool. If you see below the AppDynamics, I have mentioned something called Telegraph, Inflex, Tick Stack, right? That is one of the open source monitoring tool. Okay. Now also we'll discuss upon, if you don't have AppDynamics, then what are the various ways you will be able to troubleshoot. Yes, absolutely, you will not be able to pinpoint problems. That is for very sure, right? While you're going to do a load testing, with AppDynamics, yes, you are going to get some very good insight very easily. Without that, you might have to probably work with the developer and then have some proper logging in place so that you will be able to troubleshoot the problem. So those things we will discuss for sure. And to address it, specific questions, we will also cover the open source tool for monitoring.
Okay. One more question. As we see, like performance engineering is a like vast scope subject, right? There's no end. Like anything can be included in performance engineering. So, we'll be getting the knowledge. Suppose some issue is there in our test or script is, so we'll be able to start from where to start like debugging the issue. So we'll be getting that knowledge, or because going through every stage of these topics you mentioned, right? If we need to profile all these things, it take a lot of time. And right, at performance testing stage is like in the end. So pressure is on the testing, like complete the testing. So we'll be getting that knowledge in the course, during the course. Like if this issue is there, so should be starting the troubleshooting.
Okay. See, in the current agile world, right, where we work in sprints, that is also one scenario where we not get a lot of time. The sprint, the release cycle is only 4 weeks or 6 weeks. Correct.
Right,
So
right,
in
right.
that, how are we going to get involved? How are we going to prioritize it? Depending upon the requirements, depending upon the code changes, how are we going to include various activity? That is for the small releases, regression kind of testing. But when it comes to greenfield implementation or major code changes deployment, it has to go through proper engineering life cycle. Otherwise, there is going to be a problem, right? Time versus risk is always going to be there. And that is where we, as a performance engineer, should be able to go and justify the project manager how soon we should be able to get onboarded and what are the benefits they are going to get it. So two things. One, for the greenfield implementation or major deployments, we should get engaged early. There is no other option for it. But when it comes to minor releases in your agile sprints, we cannot go and do everything every time. So we should be able to, depending upon the change that is going to go into the sprint, we would be choosing, say, if it is going to be only changes in the front end UI, right? We might be doing some only the client side profiling and one round of load testing. If there is going to be a changes that is going to be done in the database schema, then you might be have to do a proper load testing. And then while you do a load testing, you should spend a lot of time in analyzing your AWR reports. So
Okay.
depending upon the change, you can choose that. And then depending upon the problem you see during your load test, accordingly, you depending upon the symptoms, right? If the symptoms are towards the third-party services or other APIs, then you don't need to spend time on engineering your application. So those things as well, we will cover it. You should be able to get the knowledge from the sessions, when to do, what to do.
Okay, okay. Yeah, thank you.
Yeah. So from the client side analysis, then we will move on to the, so far it is all, most of the things are going to be early performance, profiling, everything, right? Now, say during load testing, during endurance testing, we should have a monitoring in place. Otherwise, it is going to be very, very difficult to identify problems while the test is running. And so for that, from a concept perspective, we look into it, how to write a monitoring strategy, how to create a monitoring strategy for the architecture. And then we will move on to the AppDynamics for application monitoring. So AppDynamics, though it's a commercial tool, for our training purpose, we will go and get the AppDynamics tool configured with the e-library application. With the application, I'll be setting up this AppDynamics with the e-library application. We'll be setting up the Java agent for AppDynamics. and then we will try to understand what are the different components available in the AppDynamics. So one is more from the setting up this AppDynamics one, and second is installing the Java agent in the your application, and then making sure AppDynamics speaks with the your application. That is going to be one part. Second part, once the configuration is done, we will look into various components within AppDynamics, how to go and look into the web transactions, your JVM health, and then GC analysis, response time, troubleshooting the response time problems. All these things we will look into the will learn from the AppDynamics session. Similar to that, as you asked, so one of you asked, we'll also look into one of the open source infra monitoring. Right, earlier we used to use perfmon, or we used to run some Linux commands, right? That is all outdated because it is going to consume a lot of time. So with a lot of very good option available for the infra monitoring in open source, we will learn the how to install these tools, configure these tools, set it up these tools, and we will have this monitoring up and running. Okay, that is going to be a follow-up session from the AppDynamics. And third is going to be the more or less when we run a load runner or JMT test, right? We will say response time is high from a load testing tool. Developer will say no, response time is not high in their when they monitor it. So a lot of time we need to understand, is there a latency problem between load generator to application server, or application server to database server. We'll also try to learn some of the troubleshooting techniques, approaches that we can follow from a network perspective. And all these putting together, all these monitoring things putting it together, we'll try to run a small load test or stress test and create few problems, and then we'll make use of AppDynamics and these monitoring tools to go and monitor and find out the bottlenecks. So it's going to be a combination of that. We'll try to understand how to write a monitoring strategy. We'll go and set it up AppDynamics by ourselves. We'll go and configure it. We'll try to learn what are all things there in AppDynamics. We'll go and set it up the open source tick stack. We'll configure it, and then we'll go and run few load tests and stress tests, create some bottlenecks, and then using AppDynamics, we'll try to troubleshoot it. Okay, and then another big topic is going to be the Oracle database monitoring. From before going to just monitoring or analyzing the AWR, we'll try to understand the architecture. Again, very important, because we cannot just go and talk about alpha or beta to DBAs. We should know what is inside Oracle database. Right, so we'll try to understand the memory architecture, process architecture of Oracle database, and then various performance specific terminologies and components inside your Oracle database, your parsing efficiency, your buffer cache. All these things we'll try to learn from a concept perspective, and then we'll go to the database. I will be having a Oracle database in my machine, where we'll connect to that. We'll try to learn the commands to create snapshot, and we'll go and execute creating the reports, AWR reports, and then we'll analyze the AWR report. We'll also use the OEM tool, Oracle Enterprise Manager 2, to look into other metrics, what we can get it from the OEM tool directly. Okay, that is going to be part of the database monitoring. And then the non-functional requirements and engineering strategy, right? That used to be my first topic earlier, maybe 2 years back. But the reason I have put it at the last is this non-functional requirement and engineering strategy. Once we now learn all these topics, it will be easy for you to yourself to figure it out what should be part of your strategy, when to use it, what to use it, how to use it, what are all tools we are going to use it. So in detail, we'll look into the various non-functional requirements, from where we will be collecting the requirements, what are the different critical transactions, what are the typical workloads we will gather. So all these things, and part of the engineering strategy, will be part of our I would say last session, so that it won't be a black box for you. You would have seen all the engineering activity. That will be part of your strategy. We'll just try to stitch everything together and then go and create a engineering strategy. I also added two important things which we should know. though it is not a pakka engineering, but everywhere you go in the interview or new project, they will talk about DevOps. So we will have one session on introduction to DevOps, where we'll go and integrate Jenkins, JMeter, and AppDynamics. So we'll try to understand what is happening in DevOps world for performance. That's something real time information from my experience. I will share it, and we'll also go on hands-on. We'll go and do the Jenkins, JMeter, AppDynamics integration. And from a cloud performance perspective also, we will try to understand, okay, when the application is now moving to cloud, is it going to change everything? Engineering, is it going to be different? Those discussion also will do it. Though the engineering and testing is going to be same for cloud-based applications or for the traditional application, there are few things which we have to address it in addition to that, like resiliency or auto scaling techniques. So those additional scenarios you might need to understand, you might need to learn, so that you can be future ready. So I have added 2 separate sessions, which would be coming under the future readiness. Okay, so all these things is what we will cover it, and as part of the entire 3 to 4 weeks of this batch.
So this one quick thing, like for engineering strategy, you were revealing that you are going to take it up in the last, so that everyone would be able to understand. Is it possible for you to just share any template or the previous strategy document with everyone, so that we'll be having a brief idea about it to help us to understand more?
Okay, so what I will do is tomorrow, in the session, tomorrow, in the beginning maybe, right, I will show you the probably the slides which I might be using it for the engineering strategy.
Can't you share it with everyone, so that maybe later on, if we would like to refer it?
No, that will be shared. See, once you join the batch, those things will be available in the Google Drive for sure. Yeah.
Okay. Yeah, fine.
But see, the moment somebody is going to enroll, they will get access to the Google Drive on the same day, both to the sheets and the drive. So you'll have everything. So whatever I'm showing in that, let me go there again. So in the Google Drive, if you see, you will have all these documents. One, the trusted code and libraries, and then you'll have the you'll have the performance counters, and then details about the garbage collections, your DB connections pools, your network latency issues. I also have a few more things in my drive. Let me check 1 minute. All the strategy documents will be available there. Yeah.
Okay. So yeah, please go ahead. Yeah, thank you.
Yeah, a small question, like hearing resiliency a lot these days. Can you just give a single liner explanation about what resiliency is? Because we are going to cover it in our session also, no? So just wanted to understand.
Yeah, so resiliency is something we will cover it as part of the future readiness, right? I'll cover it, why it is required, what is required, what we'll be addressing it there. So resiliency, let me see if I have a slide on it. So resiliency is more about whatever testing we do, whatever engineering we do, right? There is a possibility of something is going wrong. Nobody can avoid it. When even you see Amazon, Flipkart, Netflix, I think even last week, 2 weeks back, Google, Gmail also went down. We cannot avoid it. All these people are having a very matured process and performance engineering team within them. Even then, these things happens. When these problems happen, when this chaos happens, how fast the application is getting recovered, and how the application getting is behaving is what resiliency. Say for example, if one of your downstream services is down, whether your upstream services are going to get timed out after 5 seconds, or is it going to just keep waiting for the downstream to respond, right? It is going to be one of the resiliency scenario, because if it is going to wait for 10 seconds, 20 seconds, your thread utilization is going to increase, which is going to impact your other users also. So that is one of the chaos. When your CPU increases from 10% to 90% all of a sudden, or when one of the server is going to crash, or when there is going to be a hard disk failure, or when there is going to be a memory crash, what happens to your system? Whether in the cloud, whether another server is going to spin up immediately, and then how fast your application is going to load balance your users, right? So resiliency, to tell it in a simple word, when a chaos happens, how your application is behaving, that is resiliency testing. There are tools like Chaos Monkey. We cannot go and create this chaos, right? It's very difficult to go and create chaos. I cannot go and increase my CPU to 100% immediately. I cannot go and crash my server because of a memory problem, or a disk problem, or network latency problems. So there are tools available which will create this chaos, and then we will run an endurance test in parallel to understand how my application is behaving when this chaos happens. That is the resiliency testing.
So DR
Okay.
and resiliency are the same thing, it means.
Yeah, so these names are now getting evolved or changed by these companies like Netflix or Microsoft, right? Earlier it used to be your failover or disaster recovery. Resiliency covers little bit of more chaos, but disaster recovery was more about when a server is down, or when a network is down, what happens. But this
Or the entire
resiliency
data
includes
center is
a lot of
down and
parameters.
next data center, how long it is taking to
Correct.
switch to and from one data
Correct.
center to the data center.
Yeah. Exactly. Earlier the disaster recoveries were most into the data centers, network related things. Now resiliency is more about even when of the downstream services is performing badly, or if my CPU is increased from 10 to 90%. So there are a lot of parameters that comes under the resiliency chaos. That's it. Otherwise, we have been doing this earlier in the name of disaster recovery, but now resiliency came into picture. But again, resiliency is something done by different teams in many places. There is a site reliability engineers who does this job, but going forward, it will also come into the role of performance engineer. That is why I wanted to have this as part of the future readiness.
So does engineering strategy capture these resiliency scenarios as well? That should be the part of performance engineering strategy as well.
No,
Do you
not
read?
currently. Not currently, but it might happen in the future. That is why, from awareness perspective, I have added, and then will discuss about it. But not if the currently, at least to my experience, whatever I am seeing it, performance engineer is not involved in complete resiliency engineering. We will do
Yeah.
part of it, but not the actual resiliency. We are not part of it.
But do you really recommend that we should propose to the client for these resiliency tests?
No, we should validate. They see somebody should do. We should be part of that exercise for sure. We will run our endurance test. We will go and monitor the our response time, so application server behavior. So other teams will be creating this chaos. Your infra team or server team, right? They might be creating this chaos of hardware failures or disk failures or the network failures. So it has to be a coordinated effort. You as a performance engineer should be able to validate those things. At least have this as part of your overall strategy, but you will not be responsible for creating this chaos.
Correct. Yeah, that's right.
Yeah.
But would you be able to explain few such scenarios maybe later on in the session, not today?
See, that's what. So in the future readiness, we will discuss about it for sure. Yes.
Okay. Thank
you. Yeah. Okay. So others, anyone have any other questions? Yeah, feel free to ask now, or probably even offline also. You can probably message in the group or message me if you have any questions on the topics. The schedule would be, let me go to the schedule. It will be in the same time between 9 p.m. to 10 p.m. It might run over to probably 15 minutes or 20 minutes, depending upon the way we handle the questions. And then, yeah, I would say 9 p.m. to, I would say 10:15, 10:20 p.m. is what the schedule would be. And minimum of 25 hours is what it is planned. But again, it will overrun for sure. So from 25 hours, it will go to 27 or 28 hours. But minimum of 25 hours is what is planned for this batch. Okay, so any questions that you have regarding these topics or the sessions or the timings or whatever it is, feel free to ask your question in the group. And for enrollment, you can reach out to Mr. Kumar.
Satish, is it possible to prepone the timing? Because 90 minutes.
And I was about to say, is it possible for you to postpone it by 30 minutes or 1 hour?
Yeah, see, the time, the way we have had this feedback from lot of people, and to cover the UK time, US time, and then Indian time, that is what we have come up with this time. So just ping me. I mean, this is something decided based on many people's feedback. So yeah, I don't think we would be able to alter it. Maybe once you people join and then everyone agrees, say 8 instead of 9 p.m. you want to start by 8:30 p.m. or if everyone agrees to start by 9:30 p.m. those things we can do it as a team together. But for now, yeah, it is going to be between 9 p.m. to 10 or 10:15 p.m. IST.
No, actually, if it would be early, then I won't be able to make it because I am joining from UK. And
Okay.
it's
Okay.
meeting with my
UK should be
time.
evening hour, right, for you?
Yeah. I mean, even for 9
Fine.
p.m., I need to join at 3:30 p.m., you know. So 3:30 p.m. is quite official time.
I know. Okay. Yeah.
Hi Satish, this is Abhishek. A quick question, like, could you please give us some insights on the cost involved for these for this course?
The course fee, you can get it from Kumar. It will be around 13,000 USD. But the exact course fee, you can get it from Kumar. I'm not absolutely sure, but it should be around 13,000 USD. Sorry,
Not
30,000
USD,
rupees. 30,000 rupees. I'm sorry, 30,000 rupees.
Yeah, thanks Satish. Yeah.
Thank you. Fine, guys. Feel free to post any questions, and tomorrow we will. We'll be starting the session tomorrow. So if you have any questions between now and tomorrow, feel free to message me. Or if you wanted to have a very quick discussion about any of this thing, you can also message me, and we can connect sometime tomorrow.
So what number we can connect to you, Satish? Because I have few things to ask you. Because
You
even
can
if I
you can message me through WhatsApp, and then we can just connect
you
over
have your,
WhatsApp.
can you please just share it over chat, your contact number?
Yeah, please. Yeah, I'll do it. Yeah.
Yeah, just share it so that at least.
Sure. Absolutely. Fine, guys. So then I
Hi,
think,
Satish. I have one
please go ahead.
question.
Please go ahead.
Satish, in this period of performance engineering learning, do we run any test for the test results and how it is impacting our applications and other things? Any load runner test script execution or geometry test script execution?
Yeah. Yes. We will be we will be having a load runner scripts which will be running it. As I mentioned in one of the let me go there. Yeah. So once we have this monitoring setup, right, we will be running a small load test and stress test, and then we'll have some bottlenecks created, and then we'll run this load test, and then we will go and monitor the application, and then we'll troubleshoot the problem. That will be done.
Oh, okay. Thanks, Satish. Thank you.
Yeah.
Satish, I'm still waiting for your number over chat.
Okay, chat is it? Okay, I'm sorry. I'll do it right away. 1 minute. Where is the chat? Okay, I have given it.
Yeah, thank you so much.
Yeah, no problem.
Satish, will you show any analysis report how to publish after doing the engineering things? How we will publish a report? Will you show anything of such things?
The sample reports I don't have, but I can get it for you. Not a problem.
Okay,
Yeah,
good. Thank you.
I used to maintain some Confluence pages. Confluence pages where we used to nowadays put all those analysis. We can create one as we go and do this troubleshooting, right? We'll go and create this Confluence pages with all these analysis, and we'll try to document those things. Let's do it. Yeah, we'll do it.
Okay, sure. Thank you.
Yeah, no problem. Yeah, so two things what I wanted is whoever is going to enroll, right? But be sure that you would be able to go and install these things so that you can practice, so that it will be super effective for you on top of what you're going to learn from the session. For you to get the confidence, everything whatever we are going to learn in the session, you would be able to install by yourself. All the softwares, all the tools are going to be open source, or the trial versions are available. So which means you will not have any problem in installing any of the tools whichever we are, be it is AppDynamics or your Telegraph, InfluxDB or Oracle or JProfile, all the tools, whatever we are going to use, Jenkins, JMeter, Roadrunner, or whatever it is, everything you will be able to install it in your laptop, and you should be able to go and practice it. So once you do everything whatever we learn from the session, right? I'm pretty confident that you would be able to easily crack the interviews, or easily you would be able to make your journey towards the performance engineering.
On that part only, actually, I just wanted to know the list of because even if you are starting from tomorrow, so I think from tomorrow itself we would be required those
Yeah.
setup.
Sure. I'll, as I said, right, everything is there in the Google Sheet. So once somebody enrolls, they will get access to that immediately. So it's not that I'm going to send it to everyone by doing some preparation. Right? Everything is available in the Google Sheet and in the Drive. So moment somebody is going to enroll, they will get access, so that they'll be able to go and download and set it up in their machine.
Okay.
And how the enrollment process is?
You can just message somebody from Isha, Kumar Gupta, or you can just message me as well. We'll help you out with the enrollment.
Okay, thank you.
Yeah. So you can message Kumar directly, or you can just message in the same WhatsApp group, or you can also message me directly, and we'll guide you through the enrollment.
So if I'll ping you over WhatsApp, that should be fine, correct? For enrollment?
That is fine. That is fine. Yes.
Okay.
Fine, guys. We will meet tomorrow. Thanks a lot for your time. And if you have any questions, feel free to message me.